Hello everyone, it is October 19th, 2022, and this is the libhal weekly meeting. Oh, here we go. All right, so the highlights, the agenda for today is we're going to go over some of the commits from the last sprint. Also going to go over some of the librmd progress, which I can say right now is that we're a bit held back. This has to do with the fact that there's a lot of code that actually needs to be refactored and redesigned to make the library safer and fit the style guide and the semantics we want to have for the code. When we go over libstatic list and can network, you'll kind of get some of the reasons for this. All of these changes to libhal are coming from libhal's utilities, and possibly also our design philosophy going forward is going to probably come from installing this particular library. So first things first, let's look at some commits. Libhal. And when we go over to commits, nothing too crazy from last time. Made some small changes here and there. Added howl halt, basically just a way to stop the program in a particular spot rather than having to do typing in while one continue each time. And if we ever need to instrument the halt, we can at some point. So, it's nice to have a function there so that people will use that API so we could possibly extend that API in the future and just give more functionality there. Added some, here's one big one, UDLs. Basically just added in more types. So now we have ampere, volt, Celsius, RPM. They're all about the same. They have some conversion functions. They're all just floats. So there's that. There's basically been a change from can network to can router, which we're going to talk about today. And the main big difference between these two, and I go over this later on, but for the most part, actually, I'll just go over that later. So let's not work about that now. And just a lot of work on the can router. So yeah, that's pretty much it for the updates. Things are a little bit slower at the moment. I've been busy with work and such, but also, building drivers is a lot slower of a process and it takes a lot of time, especially when you want to get it right. Nearly done. Just got it when you want to get it right. There's a lot of work that needs to be done to make it happen. Compared to just making interfaces and a couple utilities here and there. All right, so let's go over the new utility, HAL static list. So you can, HAL static list is basically a non-owning, non-allocating, doubly linked list container with O of 1 memory utilization. Basically just means that static list does not contain the list items. It doesn't allocate the memory itself. You do, in a way. You hold a reference to that allocated memory. Each element of the list is held and owned outside of the list itself, outside the static list object specifically, by some L value reference. Memory is released when the object is destroyed, goes out of scope, and memory is relocated, and the linked list is updated each time an object is moved. This means that returning, assuming you don't get copy elision, but let's not go into the details there. Let's say you return a list object by value out of a function from this linked list that you were pointing to somewhere else. The address of that object when it was inside the function is going to be different from the address of what it's going to be by value outside that function. But the way that static list works is that whenever you do a move on that particular object, it looks at the old address that it was currently at and the new address and moves its contents from its old address to its new address, and then reconnects the linked list items around it to itself. That way, every time you move the data around, whether moving it down into a function, moving it back up, you will always be pointing to that same data, but it's only statically allocated. And the moment it goes out of scope, the linked list removes that, basically no longer looks at the item and takes the two parts, or the left and right hand side, and connects them of that particular node. So basically, all of your linked list items are all throughout your stack. You can pretty much have them all completely allocated on your stack and not need to have them allocated anywhere else. But so long as there exists a reference to that particular object, it's still within scope, still usable within the scope. It'll continue to exist. it'll be part of this linked list. Usually you only care about having this one scope level deep, but if you needed to do multiple scope levels, sure, this gives you that capability. But it'll be deleted each time it goes in and out of that scope. So yeah, that's static list. Now, why did I even make this? Why did I put all this effort into this? Well, it has to do with a particular problem of the PRMR containers. Vector and string are caveats to this. But for the most part, all the other containers, you can't know when they're going to run out of memory. The cool thing about vector and string is that you can give them, just so everyone knows this, if you don't know this, in C++, we have this thing called polymorphic resource allocators. And they allow you to, rather than just allocating from the heap with normal C++ containers, it'll allocate from the buffer that you supply it with, or whatever scheme you have for allocating memory. Now, the containers like for hash map or like unordered map and map and stuff like that, or list, you can't tell them, hey, just allocate this many blocks and just use them. You can do that with vector, you can do that with string, but you cannot do that with unordered map, list, whatever. So you can't actually know when you're about to run out of memory, and they also don't behave the most naturally each time you use them. So it's not like you can say, oh, I have 10 items, I have enough buffer space for 10 items, allocate 10. It doesn't work that way. So that's one issue. So I thought that part of the API allowed you to figure out if it actually allocated. That was incorrect. And when I realized that mistake in the design there, I realized that we needed to move away from it. Hopefully it's something where you didn't have to specify like array the amount, because then you have errors, which is, what if you accidentally, added an initial one? Well, it should fault at that point. What if you what if you only are using 3 out of 10 of your slots? Well, now you're wasting space. You can always change it each time, but it's just one of those things that's error prone in general and won't be that helpful. And it's somewhat knowable, specifically in so much that like every single user of that particular static list will be allocating to it. And when it's no longer necessary in the code, it will go away. So a static list has no limitation on the number of items, basically just the amount of RAM that you have available to your thread or to your entire program, at the cost of having O of n lookup time. But I think that it's worth it. I think it's worth it in the design overall. Especially for usually when you're doing lookups, I think we're not going to have that many items in all these lists. So I think we're going to have something that has like 1,000 items in the list, or if they do, maybe this is not the right choice for their container. Here are a couple of examples. So on the left-hand side, we have void foo, and you have static list. It just takes int. And just so you know, this will also work, put in some effort to make sure that it would work with most of the standard library containers and adapters. Range-based for loops work. You should be able to use this thing with ranges algorithms. So a lot of things you should be able to use the static list for. Create an item, list item 0, list item 1 was inside of this inner scope. Once it leaves that inner scope, it will, at that time it was the tail. It will basically reconnect or reset up how do I say this? It will modify the linked list right when it escapes, once it goes away, once it can no longer be referenced. Then list item 2 becomes the new tail. And you can print it out and you'll only see 0 and 2. And if you have way more items or whatever, it'll handle all of that. On the right-hand side, we have, we passed in a reference to some lists. We're going to do some work with this thing, and we realize we need to allocate a couple of items here, or at least one of these items. So we return up the item. And the interesting thing here is that at the time when that particular function on bar, the new item was created, the linked list was pointing to it in that stack. When you returned it, and if it used a move operation, there's reasons why it wouldn't happen, but if it moved out of that particular function to the calling function, now the address of item becomes the thing that's actually on the linked list. So no matter where you move it up and down a stack, it'll always point to that data. And then that's pretty much just that part there. Now we have our next, or our last little example. I hoped at some point to actually show a fully fledged driver, the librmd driver that actually utilizes this, because that's the whole point of why I'm doing this. Here we have a driver, and we have some static list of callbacks. In the initializer list, we just initialize, we push back an empty default constructed callback. And then inside our function, we take that particular list item and we assign it to some lambda, referencing us, this. Then when static list of whoever's owning or controlling static list wants to go through all of the callbacks through all of the different libraries, it now has a linked list of all of them. And so long as those objects continue to exist, because the moment that this object destructs for whatever reason, it'll have to call all the destructors, and the destructor for static list item will simply remove itself from the list when that happens, deallocating that memory in a way without using any dynamic memory. So yeah, that's kind of the hope, is to be able to attach something like this. The further hope is actually to have the callback track where the driver moves to, and hopefully without needing to implement our own move constructor, because that'd be annoying. But yeah, tracks the driver that it's held within, so that you don't have to. Yeah, just it should make developing drivers that have callbacks that need to be returned by value exceptionally easy. Otherwise, it becomes exceptionally difficult, or it can become exceptionally difficult. So, or you have to do some things where you have to add in some limitations that aren't that nice. So, CAN network to CAN router redesign. I actually missed one of the biggest points about this. The whole reason why there's a change between CAN network and CAN router isn't for the data structure reasons. That was another thing that came up. But actually because when I was looking at the RMD library, I realized that we have callbacks. We have interrupts that get called whenever we have a new message. But our code is designed to be polling. The way that CAN router worked is that it would have a map of different values, and anytime we got a message in, we would just port it over to that particular mailbox, that particular item in the key value store. That meant that the user had to poll those particular messages until they were ready, when they could have just put up a callback and whenever it was ready, have that callback be called. And if you wanted to poll at some later point, you could. But this allows users to basically choose how they want this stuff handled. And in the RMD, the smart motor situation, or I'm sorry, smart motor case, the smart motor case, the actual way to communicate to the motor is just to send out a message and ignore the response for the most part. And we only really need the response for feedback. So we can pretty much ignore, we can pretty much just send all of our actions, our actuation actions to the servo, everything will be fine. But on the feedback side, we can just, and the user can, poll on that updated data whenever they want to, if they want to, in their particular use case. So yeah, that's pretty much the big part of this whole redesign. The other part here is that we're slimming it down as well. It's also going to use static list. And yeah, because of all of this is the reason why the librmd progress has been stalled. But I think once we get this ready, this will actually improve a lot of other areas for libhal. So yeah, that is pretty much the today's meeting.